Hey guys! Tonight we're going to embark on an epic, yet remarkably soothing journey into the very beginning of everything. Imagine floating in an infinite, timeless void surrounded by profound stillness, a gentle hum of potential that precedes the first spark of existence. We'll drift through the cosmic quiet, explore the nascent energies of a universe just about to unfurl, and contemplate the grand, silent moments before light touch darkness. It's a tale so vast and so old, so utterly beyond comprehension, you probably won't survive this without at least nodding off a few times. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. If you're listening live, drop your location and local time in the comments. It's always fascinating to see where everyone is drifting from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Our journey tonight begins in a place that defies imagination, a state of being that isn't really a place at all. You are, in a sense, experiencing the moment before the moment. Picture, if you can, absolute nothingness. Not empty space, because space itself doesn't exist yet. Not darkness, because light hasn't been invented. Just a profound, unimaginable cosmic whisper, a state of pure potential, a mathematical singularity perhaps, or a quantum foam bubbling with fleeting, ephemeral possibilities. This is the realm before the Big Bang, before time itself began its relentless march. It's a concept that makes your brain feel a little fuzzy, doesn't it? Like trying to remember a dream you had before you were born, or perhaps trying to grasp the taste of a flavor you've never encountered. It's the ultimate blank canvas, awaiting the first stroke of creation. In this timeless void, there is no up or down, no here or there, just an infinite, profound stillness, a quietude so absolute it resonates with a gentle hum of unmanifested energy. It's the universe in its ultimate infancy, or rather, pre-infancy, a theoretical construct that physicists ponder with furrowed brows and endless equations. Mainstream cosmology suggests that all matter and energy, all of space and time, existed in an infinitely small, infinitely dense point. Think of it as the ultimate minimalist apartment, not just tiny, but so perfectly condensed it contained the blueprints for everything to come. It's where all the laws of physics, all the fundamental forces, all the atoms that would one day form stars and planets and us were coiled into an unbelievably tight knot. One quirky tidbit about this pre-Big Bang state is the concept of a false vacuum, a theoretical state in quantum field theory that could suddenly decay into a true vacuum, releasing immense energy and potentially kicking off a new universe. It's like the universe was a precarious Jenga tower, just waiting for the right tap to unleash an explosion of cosmic proportions, not of destruction, but of pure, unadulterated creation. This isn't just theoretical musings. It's a profound idea that hints at a universe not just emerging from nothing, but perhaps from a state of incredible, almost unstable potential energy, just waiting for the conditions to align for its grand debut. You are floating in this pre-cosmic soup, undisturbed, unformed. There's no pressure, no temperature, no sound, just an endless, quiet readiness. It's the ultimate calm before the ultimate storm, if a storm could create everything. Imagine it as the deep, silent breath before a cosmic sigh, the serene pause before an explosion of light and matter. Scientists still argue whether the universe originated from this singularity or if it's part of a larger multiverse, where Big Bangs are just cosmic Tuesday mornings, endless cycles of birth, expansion, and perhaps eventual contraction, leading to new births. The mysteries here are so vast, so profound, that even the most brilliant minds often resort to metaphor and philosophical pondering, stretching the limits of human understanding. You don't need to understand it, though. Just feel the profound quiet. It's the ultimate lullaby, the stillness of creation before the very first dawn. It's the perfect environment for absolute relaxation, a deep, resonant peace that precedes the very concept of disturbance. As you drift here in this primordial calm, you are a silent witness to the most fundamental potential that ever existed. You are experiencing the universe in its most embryonic form, a state of perfect, unburdened possibility, a place where all future wonders are still mere whispers. Allow yourself to be enveloped by this profound tranquility. Section 2. The First Spark. From that unimaginable state of pure potential, a realm beyond emptiness, beyond even the language we have to describe absence, emerges something astonishing. A subtle shift, a whisper in the cosmic void, barely more than a hint of intention. From that profound, breathless stillness, where time has yet to be born, and space lies unborn in its cradle of infinite non-being, we approach the threshold of everything. This is not merely the beginning, this is the beginning of beginning. You are now standing at the edge of all edges, staring into the moment that transformed boundless nothingness into the seed of everything that would ever be. This is the first spark. Imagine, if you can, a moment so ferociously abrupt, so violently creative, that it bypasses comprehension altogether. A moment not with sound, because there is no air, no vibration, no distance yet. Instead, it is the instant of unbounded expansion, a detonation of pure potential wrapped in silence. It's not a bang as our ears might imagine, but a flashpoint of transformation, a shift from absolute void to an almost inconceivable density and energy. In that timeless fragment of reality, smaller than a zeptosecond, briefer than our minds can faithfully hold, everything you know, everything that has ever existed, and all that ever will exist was compressed into a single, infinitely small singularity. And then it began. An eruption, a release, not through space, but into space, for space itself was birthed in this very instant. Time, too, blinked into being, stepping forward from its endless slumber to start its inexorable journey toward the future. In this instant of cosmic creation, the universe began to stretch, not like a balloon being inflated, but more like space itself was inventing the concept of distance as it grew, creating room for everything to come. What was once nowhere became somewhere. What was once nothing began to dream of structure, of force, of matter. This is the moment of the Big Bang, not an explosion in space, but the creation of space itself. In that impossibly hot, dense state, reality underwent a transformation so sweeping, so profound, that even the most advanced equations we've crafted strain under the weight of its implications. Cosmologists, using the faintest echoes of light and energy still lingering in the cosmic microwave background radiation, have traced this beginning back to a time before time, when the fabric of the cosmos was still being woven. Now imagine the temperature, searingly, impossibly hot. Not in any way fire-like, but with an intensity of energy where fire hasn't even been imagined yet. The heat is so great that the very laws of physics as we know them are still deciding how to behave. In these first fleeting instants, all the fundamental forces, gravity, electromagnetism, and the nuclear forces, are not separate things. They are unified, indistinct, merged into a single elegant force. As the universe expands and cools, these forces begin to decouple, like colors slowly separating from pure white light. This is symmetry breaking, an idea so beautiful, so foundational, that it's like watching nature compose the laws of reality in real time. Then comes inflation, not the kind you fear in economic terms, but something far more radical. In less than a trillionth of a second, the universe undergoes a growth spurt so enormous that it defies all common sense. We're talking about an expansion by a factor of at least 1026, or a million times, in a time span shorter than 10⁻32 seconds. To put that in perspective, if a proton suddenly ballooned to the size of the observable universe in less than time it takes across a single atom, you'd still be underestimating the speed and scale of this transformation. It's staggering, it's absurd, and yet it makes everything make sense. Without inflation, the cosmos would be a chaotic, clumpy mess. Instead, we find a universe that is astonishingly smooth, remarkably flat, and surprisingly uniform on grand scales. And still, there are no particles yet, no atoms, no stars or galaxies. Just an unimaginable ocean of pure energy, a radiant, featureless fog of potential. This is the primordial soup before it earned its ingredients. No up quarks, no down quarks, no... Section 3. Expanding Emptiness. From the blinding, silent eruption of that first spark, our journey glides onward, drawing you ever deeper into the unfolding mystery of the universe. The cataclysmic birth is behind us, yet its echo remains, not as noise, but as motion, an eternal expansion. Welcome now to the phenomenon known as expanding emptiness, a phrase that seems paradoxical, but is, in fact, the most accurate way to describe this new chapter in cosmic evolution. What you're witnessing is not just the aftermath of creation, it is creation in motion. Not a place filling with things, but a space that is making more of itself. Imagine the universe at this moment, not the grand star-speckled sky you know, but an almost incomprehensible vastness, small by future standards, but already growing at speeds beyond the reach of light. It is cooling, ever so slightly, as it stretches. Not cooling like the gentle drift of air across your skin, but more like the sudden chill of compressed gas rushing into open space. The primordial heat, once so densely packed it defied the idea of temperature, is now thinning. And with that thinning comes order, slowly, elegantly. This is no passive backdrop, no inert emptiness. Space itself is expanding, like an ethereal fabric being unrolled across an infinite stage. There is no center to this growth, no edge. Every point moves away from every other point, not because they are being pushed, but because the space between them is growing. It's not just that things in the universe are drifting apart, it's that the universe is making more apartness with every passing moment. And in this space, you float, silent, weightless, and wide-eyed. You are a ghost of curiosity in a place where time has barely begun to speak, but the future already listens. In the earliest instance after the Big Bang, the universe was unimaginably hot and dense. Not just hot in the way a star is hot, but with a kind of pressure and temperature that makes the heart of a supernova seem cool. It was like a subatomic pressure cooker, a roiling mass of undivided energy. But with expansion came transformation. As the universe grew, it cooled. The energy dispersed, and with cooling came structure, not physical yet, but conceptual. The smooth, unified force of the early universe began to fracture. It split, not with violence, but with necessity, dividing into the fundamental interactions that would eventually choreograph the motion of galaxies, the dance of atoms, and the spark of consciousness. First, gravity peeled away from the unified field, an invisible thread that would one day draw stars together and keep planets from drifting into the void. Then came the strong nuclear force, the glue that would hold the hearts of atoms together. Next, the weak nuclear force, and finally, electromagnetism, the light bringer, the sculptor of chemistry and electricity. This unraveling, known as symmetry breaking, is one of the most elegant ideas in modern physics. Imagine a perfectly blended smoothie separating back into strawberries, bananas, and yogurt, but on a scale where the ingredients are the laws of reality themselves. And you, dear observer, are drifting through this unfolding. An ethereal wisp of awareness in a universe that is still raw, still unfinished. You are weightless here, untouched by gravity, unshaped by atoms. Everything is still far too hot and simple for anything so complex as you to exist. Yet, here you are, watching. One of the curious features of this early expansion is what cosmologists call the cosmic horizon. Because the universe has been expanding so quickly since its birth, there are regions of space whose light has not had time to reach us. Even now, as our most powerful telescopes gaze into the deepest past, there are entire swaths of reality beyond our reach. Not because they don't exist, but because their light simply hasn't arrived yet. It's a horizon not of earth or sea, but of visibility. A limit not set by geography, but by the physics of space and time. It's like standing in a vast, dark plain, holding a flickering candle, and realizing there are entire mountains out there, unseen, unknowable, yet just as real. And beyond this horizon, more mystery, more possibility. Still, for now, the universe remains deceptively simple. There are no stars yet, no planets, no galaxies spinning in majestic spirals. Just light and energy, thinning, stretching, cooling. The matter we are made of exists only as plasma, a chaotic mix of subatomic particles too energized to settle into anything resembling structure. It's a universe in waiting, a stage being built, slowly, for acts that have not yet begun. And yet, in this emptiness lies the blueprint for everything to come. The subtle variations in energy density, mere wrinkles in the smoothness of the early cosmos, are the seeds from which all future structure will emerge. These tiny irregularities, born from quantum fluctuations stretched during inflation, will become galaxies, clusters, and cosmic filaments. Complexity, in all its unimaginable richness, is encoded in this expanding emptiness like a secret folded into origami. The future is written here, in silence and scale. Some say this expansion will never end, that the universe will continue to grow, to cool, to dilute forever. In this vision, everything ends not with a bang, but with a whisper. Stars burn out, galaxies drift apart, and the cosmos freezes into dark, diffuse quiet, the big freeze. Others suggest a different fate, a cyclical one, that gravity may someday halt this expansion, pulling everything back into a single point in a cataclysmic big crunch. And there are those who dream of a third path, a dynamic equilibrium, a steady state, where creation and dissolution balance forever. The truth, as always, remains elusive. And yet, as you drift here, untethered in the cooling sea of post-birth reality, none of these possibilities feel frightening, only calming. You are in a moment of perfect transition, where the universe is no longer what it was, but not yet what it will be. It is breathing, and you are breathing with it. Feel the immensity of it, the quiet, the stretch, the endless possibility woven into the void. This is not absence. This is the canvas on which existence is painting itself, slowly, lovingly. And as you float, bathed in the distant, ancient glow of the first light still finding its way across the sky, you are free to rest. Let the silence carry you. The universe is still expanding. You have time. Section 4. The Subatomic Dance. From the grand silent expansion of that ever-stretching emptiness, our journey carries you now into a realm that is both delicate and explosive, a world invisible to the naked eye, yet foundational to all that is, was, and will be. This is not the world of stars or planets, not even of atoms or molecules, but something far more fundamental. Welcome to the subatomic dance. Imagine the universe now, a few millionths of a second after its birth, no longer a pure seething plasma of energy, but just beginning, to cool enough to allow structure to emerge on the smallest possible scale. This isn't yet the familiar matter of tables and trees and stardust. This is the raw essence, the ancient alphabet of creation. What you are about to witness is not a construction, it is a composition. Not architecture, but choreography, a dance. Float with me now, silently and invisibly, through this swirling nascent sea. Around you ripple waves of energy, flickering with potential, pulsing with possibility. Out of this primordial field, particles begin to wink into existence, not singly, but in elegant, paired bursts. Matter and antimatter, spinning into being like twin sparks from a single flame. Quarks and antiquarks, electrons and positrons, neutrinos and antineutrinos. Each pair a mirror, a promise, a symmetry. And just as quickly, many of them annihilate in bursts of raw light, collapsing back into energy as quickly as they arrived. But, and this is the great twist in the tale, something isn't quite even. There is an imperfection, a cosmic imbalance, so small and so crucial that it defines the entire future of the universe. For every billion pairs of matter and antimatter, there is one extra particle of matter left behind, a flaw, a gift, a single beat skipped in the rhythm of the cosmos. Without that tiny asymmetry, this dance would have been self-canceling, a brief flicker before endless silence. Instead, that lone excess of matter, multiplied over countless interactions, becomes the foundation for every atom, every star, every breath, and every dream. Without it, there is no you to observe this dance at all. Now you are drifting through the quark epic, a fleeting chapter lasting mere microseconds, yet profoundly significant. This is the time when quarks, the tiniest known building blocks of matter, move freely in an unimaginably dense soup of energy. These particles are not yet bound into protons or neutrons. They are wild, unconfined, darting and spinning, jostling in a high-temperature frenzy. Picture a room full of toddlers with unlimited sugar and no water. Section 5. Particle Harmony. From the chaotic yet precisely tuned subatomic dance of quarks and leptons, our journey now guides you softly into a new and exquisitely orchestrated movement, the phase of particle harmony. The wild flurry of unbound particles is slowing, cooling, settling into something more organized. The energy that once crackled and collided in wild spontaneity begins to follow more structured rhythms. The symphony of the cosmos is still young, but its melody is beginning to take shape. Imagine the universe, still blisteringly hot by any reasonable standard, yet no longer the infinite inferno it once was. Temperatures have now dipped below 1 trillion degrees Celsius, an almost unfathomable number to the human mind, yet critical for what is about to unfold. In this slightly more temperate cosmic furnace, something miraculous begins to happen. The basic rules of reality, gravity, electromagnetism, the weak and strong nuclear forces, are no longer abstract potentials. They are now in full effect, asserting their personalities, carving distinctions into the previously undivided chaos. This is not just a moment of cooling, it is a moment of emergence, of identity, of structure. It is here, in this quieting storm of energy and motion, that the first stable composite particles begin to form, the protons and neutrons, the foundational components of all atomic nuclei. These are not unfamiliar names. These are the particles that make up every atom in your body, every star in the sky, every planet that will ever form. But in this moment, they are newborns, fragile, fleeting, yet destined for greatness. Think back to those unruly quarks, free-floating, high energy, bouncing around like toddlers in zero gravity. Now, under the cooling influence of the expanding universe, they begin to feel the grip of the strong nuclear force, a force so powerful, so focused, that it can hold together even the most stubborn quarks in tight embrace. Quarks begin to bind in triplets, forming baryons like protons and neutrons, held tightly by the exchange of particles known as gluons. It's as though the dance floor has changed tempo, the music shifting from a frenetic drumbeat to a slow, elegant waltz. You are drifting among them now, watching this transformation unfold from the inside. You feel no heat, no pressure, only the shifting pattern of creation around you. Each new proton or neutron is a miracle of balance, a moment where chaos agrees to form. It's like the universe itself is exhaling, pausing after a long inhale of fire and force. Here's a delightful twist. During this period, there is a brief yet fascinating equilibrium, a cosmic game of musical chairs, where protons and neutrons flip back and forth. Through interactions with neutrinos and electrons, neutrons can become protons and protons can become neutrons. The ratios are constantly in flux, guided by temperature and density. For a fleeting time, the line between these two particle types blurs, as though the universe is undecided, trying to determine which arrangement will yield the best future. This interconversion is no idle curiosity, it's essential. The final balance between protons and neutrons will directly shape the formation of the lightest elements in the universe. Without enough neutrons, no helium could form. Too many, and the universe would be radically different. Somehow, delicately, it all lands just right. The dance continues, always one beat ahead of entropy. Meanwhile, the electromagnetic and weak nuclear forces are stepping more prominently into the spotlight. Electromagnetism, the force of light and electricity, begins to dictate how charged particles interact. The weak force, responsible for radioactive decay and certain particle transformations, helps drive those proton-neutron conversions and sets the stage for future nuclear reactions. Each force has its role, its rhythm, its range. Each one a voice in the growing chorus of cosmic rules. This is a construction site of reality, a scaffolding not built of steel and stone, but of laws and constants. Here, the rules that will govern chemistry, biology, and even thought are being laid down. The elegance of it is staggering. What was raw possibility is becoming precise mechanics. The randomness of the Big Bang is becoming the reproducibility of physics. This is not just harmony. It is order from chaos rising silently like a cathedral of invisible scaffolding. And yet, we are not finished. For all the beauty of protons and neutrons, there are still no atoms. Section 6. The Cooling Cosmos. From the foundational harmony of newly formed protons and neutrons, particles that once danced freely in the inferno of early existence, our journey now enters a moment of profound stillness and change. This is not a moment of chaos or explosion. This is a moment of settling, of clarity, of transition from noise to silence. Welcome to the cooling cosmos, a period that reshaped the universe not through violence, but through serenity. Imagine the universe now, vast beyond comprehension, yet still in its infancy, only 380,000 years old. That may sound ancient, but compared to the 13.8 billion years it has existed, this is a baby barely beginning to blink. Expansion continues. Space still stretches like an ever-unfolding scroll, but the furious energy of the earlier epochs has mellowed. The temperature has finally fallen to a critical point, about 3,000 Kelvin, a temperature cooler than the surface of the hottest stars, yet still searing compared to anything on Earth. But here, this temperature drop is not just a number. It is a threshold. Below this line, a new kind of order emerges. Before now, the universe had been an opaque plasma, a thick, glowing fog of light and free-floating electrons bouncing endlessly off protons and helium nuclei. Photons couldn't travel far without being scattered like headlights in a blizzard. The cosmos, for all its energy and promise, was blind to itself. It could not see, it could not be seen. But now, something miraculous begins to happen. The electrons, which had been too wild and energetic to settle, finally calm. They slowed just enough to be caught in the gravitational embrace of protons and helium nuclei. They spiral inward, drawn not by chance, but by the inevitable pull of electromagnetic attraction. One by one, atoms form, stable, neutral, whole. Not the complex atoms of chemistry class, but the simplest elements, hydrogen with its one proton and one electron, and helium with two of each. No oxygen, no carbon, no gold, just the humble foundational atoms that will one day build everything else. This moment is called recombination, though the term is slightly misleading. It suggests a return, a restoration, but in truth, this is the first time electrons and nuclei have ever combined. It's a birth, not a reunion. And with the formation of these neutral atoms, the universe undergoes one of its most transformative changes. It becomes transparent. For the first time, light is free. Photons, no longer trapped by constant collisions, begin to travel unimpeded through space. The fog lifts, the cosmos clears. It is as though the universe has opened its eyes and taken its first long look into itself. And that light, the very photons released in that moment, are still moving, still traveling, still illuminating. You are floating within this newborn clarity, adrift in a vast sea of newly formed atoms, surrounded by the universe's first true openness. It's quiet now, not empty, but peaceful. The roiling chaos of earlier times has faded, replaced by a cool, gentle hum of potential. There are no stars, no galaxies, no heat beyond the residual warmth of expansion. Only hydrogen, helium, and light. That light, the ancient light from this very era, is what we now detect as the cosmic microwave background, or CMB. It is not bright to our eyes. In fact, it's a faint whisper, now cooled to just a few degrees above absolute zero, stretched thin by billions of years of cosmic expansion. But it is still here, all around us, a perfect, omnipresent echo of this moment, a snapshot of the universe as it was, frozen in time, still visible today in every direction we look. Scientists have mapped it, studied it, and revered it. It is, in a way, the universe's baby picture. Fuzzy, yes, but precious beyond measure. One quirky and astonishing fact about this light, it's incredibly uniform. Wherever you look in the sky, it's almost exactly the same temperature. This near uniformity is a key piece of evidence for the Big Bang and the theory of cosmic inflation. And yet, it is not perfectly uniform. There are tiny fluctuations, small temperature differences, mere thousandths of a degree, that hold the seeds of future complexity. These are the echoes of quantum ripples stretched across the cosmos, the slight variations in density that gravity will one day amplify into stars, galaxies, and clusters. Section 7. The Dark Ages. From the serene clarity of the cooling cosmos, where the first neutral atoms were born and light first traveled freely, our journey now leads into a chapter of cosmic history defined not by brilliance, but by stillness. It is a time without light, without stars, without spectacle. It is the hush before the symphony, the deep breath before illumination. This is the dark ages of the universe. Imagine the cosmos now, vast beyond imagining, transparent but devoid of radiance. The fog has lifted, yes, but no lights have been turned on. You are floating in an endless night, the stars not yet kindled, the galaxies not yet drawn. The only glow is the fading memory of the cosmic microwave background, now stretched into invisible wavelengths by the ongoing expansion of space, like the echo of a lullaby slowly fading into the distance. It is still here, all around you, but you no longer see it. The cosmos is open, but it is dark. This era begins roughly 380,000 years after the Big Bang and extends forward for hundreds of millions of years, perhaps until around 400 million years post-Big Bang. Despite the dramatic name, these dark ages are not sinister. They are not cold in feeling, though the universe is, in fact, cooling. They are not threatening. They are quiet, peaceful. They are the longest, most contemplative pause in all of cosmic history. A moment of still potential where the pieces have been set in place, and yet nothing has yet begun to shine. During this time, the universe is filled with a smooth, neutral gas, mostly hydrogen, with a bit of helium, both created during the earlier epoch of primordial nucleosynthesis. These atoms drift gently through space, expanding with the universe, spreading thinner with each passing eon. But there is something else here too, something utterly invisible yet gravitationally dominant: dark matter. This mysterious form of matter, which does not interact with light or electromagnetic radiation, outweighs regular matter by roughly 5 to 1 and quietly shapes the landscape of the cosmos. You drift through this vast open night. There are no constellations to guide you, no galaxies to admire, no starlight to warm the void. Yet you can sense something just beneath the silence: a tension, a readiness. It is as if the universe is waiting, a pianist's fingers hovering above the keys, a dancer poised on the edge of motion. One curious truth about this era: despite its darkness to human eyes, the universe was still bathed in a faint microwave glow. The same CMB that once blazed across the sky has now redshifted, stretched by billions of years of cosmic expansion into longer and longer wavelengths. It remains one of the brightest sources of radiation in the cosmos at this time, just not within the visible spectrum. If you could somehow tune your eyes to microwave frequencies, this would be a cosmos shimmering with invisible light. But to you, it appears as pure blackness. A universe not empty, but merely waiting to be seen. This era is not idle, far from it. Deep beneath the silence, gravity is hard at work. Remember those tiny ripples from quantum fluctuations gently etched into the early density of the universe? These irregularities are the seeds from which everything else will grow. Slightly denser regions of gas begin to draw in surrounding matter. Dark matter, already clustered into vast invisible scaffolds, provides the gravitational wells into which hydrogen and helium now fall. The process is unimaginably slow, a creeping accumulation over tens of millions of years. But it is happening. These denser pockets become tighter, heavier, hotter. Imperceptible at first, but gradually, pockets of gas begin to collapse under their own weight. In this near-perfect vacuum, in this ocean of neutral atoms, the stage is being set for something extraordinary: the birth of the first stars. And yet, here in the Dark Ages, those stars are still dreams. Their light still a promise. You drift through this immense, silent darkness, surrounded by possibility, but not yet its realization. There is beauty in the simplicity, a quiet elegance in this vastness. Nothing rushes here. Everything takes the time it needs. There are no supernova, no black holes, no carbon, no life. There is only waiting, and the promise of all that is to come. Astrophysicists still...
Section 8. First Light. From the profound stillness of the Dark Ages, that vast, cold expanse of neutral hydrogen and helium, our journey now carries you gently into a moment of incomparable beauty, the first true awakening of the cosmos. After hundreds of millions of years of quiet potential, of structure building and silence, the universe is ready to open its eyes. This is the moment when darkness ends. This is first light. Imagine the scene. For ages, gravity has been quietly pulling at the slightly denser clumps of gas and dark matter scattered through the cosmos, the result of ancient quantum ripples stretched thin by cosmic inflation. Over millions upon millions of years, these invisible hands have drawn matter inward, ever so slowly, concentrating it into tight knots of mass and pressure. And now, roughly 400 million years after the Big Bang, the first true transformation occurs. The gravitational collapse becomes so intense that the hydrogen gas heats to incredible temperatures. The pressure reaches a tipping point, and then, ignition. Nuclear fusion, that most sacred of stellar alchemies, begins. Hydrogen atoms are crushed together, their protons fusing into helium, releasing titanic amounts of energy in the process. What was once cold, neutral gas suddenly blazes with light. The first stars have been born. The darkness is broken. These ancient pioneers of illumination are known as Population 3 stars, a name that belies their cosmic primacy. Unlike the stars we see today, these were massive, pure, and primordial. Formed entirely from hydrogen and helium, they lacked the heavier elements, carbon, oxygen, iron, that future generations of stars would be enriched with. And because of this purity, they could grow far larger than most stars we know. Some may have reached hundreds or even thousands of times the mass of our Sun. You are floating now, a silent and invisible witness, as the first pinpricks of light begin to glitter across the black tapestry of space. Like sparks from a flint striking dry kindling, these stars flare into being, hot, blue, and blindingly bright. They do not appear alone. Often they form in clusters, gathered into the universe's first proto-galaxies, early communities of light amidst a vast ocean of night. It's as though, after a long and dreamless sleep, the cosmos has remembered how to speak. Its first words uttered in the language of starlight. But these first stars live fast. Their enormous mass means they burn through their nuclear fuel at a furious rate. While our Sun will shine for billions of years, these ancient giants last only a few million, a cosmic blink. They are brief but spectacular. And in their short lives, they begin a transformation far greater than their individual brilliance. As these stars blaze, they emit not only visible light, but high-energy ultraviolet radiation, capable of stripping electrons from neutral atoms. This marks the beginning of the epoch of reionization, a phase that will fundamentally reshape the universe once again. The photons from these early stars begin to ionize the surrounding hydrogen gas, creating vast expanding bubbles of ionized matter. What was once a smooth, neutral fog becomes riddled with growing pockets of clarity. The cosmic night is being cleared by firelight. And so, bit by bit, light spreads. The stars multiply. The first galaxies form, merging, growing, evolving. The invisible scaffolding of dark matter, laid down in silence, now reveals its hidden purpose, guiding ordinary matter into patterns, forming the grand structures of the cosmos. The cosmic web, a vast network of filaments and nodes, begins to emerge with galaxies gathering at its intersections like cities at the crossroads of invisible highways. Here, among these first stars, you feel the heat, not physical, but emotional, a rush of something ancient and proud. Creation is no longer passive. It is brilliant, explosive, awake. One delightful detail: the first stars, in their brief lives, also sow the seeds of complexity. In their cores, hydrogen fuses into helium, and helium into heavier elements. And when they reach the end of their lives, often in cataclysmic supernovae, they scatter those elements across space. Carbon, nitrogen, oxygen, iron. These ingredients will be. Section 9. Galactic Nurseries. From the dazzling emergence of first light, when the cosmos awakened with the ignition of its earliest, most luminous stars, our journey now carries you into a time of even greater grandeur, a time of architecture and assembly, of form taking hold amidst the sea of potential. This is the age of galactic nurseries. Imagine the universe no longer as a vast empty void, nor a sparse scattering of solitary stars, but as a canvas now speckled with radiant clusters, like embers glowing in the ashes of a great fire. These clusters are not yet the galaxies we know today. There are no elegant spiral arms or smooth elliptical glows, but they are the seeds, the rough, chaotic blueprints for the cosmic cities to come. This era begins around 400 million years after the Big Bang and extends across billions of years through an epoch of continual assembly. Here, the universe is a construction zone of magnificent scale and elegant complexity. The dark matter scaffolding, formed silently during the earliest epochs, now begins to assert itself fully, its gravity drawing ordinary matter, hydrogen and helium, into its hidden web. In these gravitational wells, proto-galaxies take shape, merging, stretching, and growing into the first monumental structures of light and motion. You are floating through this sprawling worksite, a silent observer as the universe conducts its slow choreography of creation. Stars swirl in loose, ragged groups, pulled together by unseen hands. Gas flows inward, cools, collapses. Clouds of hydrogen ignite into new stars, which explode into supernovae, enriching their surroundings with heavier elements. It's an endless cycle of birth and rebirth, a galactic tide sculpted by gravity's patient pull. And yet, this formation is not clean. The early galaxies are messy, irregular, shaped by chaotic collisions and uneven flows of gas. They are cosmic toddlers, wild, unbalanced, full of energy. They lack the symmetry of the spiral galaxies we admire today. But what they lack in elegance, they more than make up in enthusiasm. One quirky truth about these ancient galactic nurseries: they were frenzied star factories. Unlike modern galaxies which form stars more slowly, these early structures were bursting with activity. Fueled by a near-limitless supply of pristine hydrogen gas, they created stars at astonishing rates. Entire clusters were born in rapid succession, with young, hot stars pouring out ultraviolet radiation and heavy elements, transforming their surroundings at an incredible pace. These galaxies were not just forming stars, they were shaping the future of cosmic chemistry. And the stars, in turn, shaped their galaxies. Massive stars lived fast and died young, their deaths marked by violent supernovae that blew vast bubbles in the interstellar gas, triggering more star formation in a domino effect of light and energy. Black holes, too, may have begun to form at the hearts of these galaxies, some eventually growing into the supermassive black holes that anchor the centers of galaxies like our own Milky Way. As more galaxies form, the universe begins to take on its modern appearance, not fully, but in suggestion. A grand cosmic web is emerging, with galaxies clustering along filaments of dark matter that stretch across billions of light years. Between these strands lie vast voids, regions of space so empty they are nearly forgotten by gravity. The cosmos is no longer uniform. It is structured, layered, and alive. You are drifting now through these embryonic galactic realms, each one a brilliant cloud of stars and gas, some still colliding, others spinning into early disk shapes. You witness the quiet violence of creation, not as chaos, but as a kind of slow-burning artistry. The universe is sculpting itself, one gravitational brushstroke at a time. And through it all, the questions remain. Where did the original seeds of these structures come from? Were they the result of quantum fluctuations magnified by inflation, a randomness baked into the very beginning of the universe? Or did something more exotic contribute, perhaps unknown particles or new physics beyond our current models? Theoretical astrophysicists continue to explore these mysteries, their simulations running endlessly, trying to recreate what you are now witnessing firsthand. And so, in this age of grand assembly, feel the weight of what is being built.
Section 10. Stellar Alchemy. From the majestic formation of galactic nurseries, where clusters of stars first gathered under gravity's patient hand, our journey now takes us to the heart of cosmic creation itself. Welcome to the era of stellar alchemy, where the universe, now filled with countless massive, short-lived stars, becomes a sprawling chemistry lab of unimaginable scale.
Imagine the vast expanse of the cosmos, lit by these colossal burning engines, radiating light so intense it is almost beyond human comprehension. These stars, each a furnace of incredible heat and pressure, are not merely radiating light, they are forging the very elements that make up everything we know and everything we are. This era begins as soon as the first stars ignite, around 400 million years after the Big Bang, and continues throughout the early stages of the universe's life. These first stars, called population 3 stars, are far more massive than anything we see today. Some are hundreds, even thousands of times the mass of our Sun. Their internal temperatures and pressures are so extreme that they become the perfect crucibles for stellar nucleosynthesis, the process by which lighter elements are fused together to form heavier ones. The simplest stars, like our Sun, fuse hydrogen into helium, a relatively straightforward process. But the first, most massive stars did something far more extraordinary. They fused hydrogen and helium into progressively heavier elements, all the way up to iron. This process of nuclear fusion is the core of stellar alchemy. In the heart of these titanic stars, hydrogen atoms are squeezed together under immense pressure, fusing into helium and releasing vast amounts of energy in the form of light and heat. As the star's core continues to burn, it begins to fuse helium into heavier elements, creating elements like carbon, oxygen, and nitrogen. These are the very building blocks of life, life as we know it, and without them, the universe would be a very different place. But the story doesn't end with the birth of these elements. As these massive stars continue their alchemical work, they enrich the surrounding cosmos with the heavy elements that they forge. These elements, the very ones found in the air we breathe, in the earth beneath our feet, and in the stars above, are scattered into the vast expanse of the universe. Carbon, oxygen, nitrogen, these are the essential ingredients for life, the chemical foundation for everything from the simplest bacterium to the most complex human being. And yet, the process of stellar fusion has limits. The most massive stars continue to burn heavier and heavier elements, fusing helium into carbon, carbon into oxygen, oxygen into neon, and so on. But eventually they reach iron, the heaviest element that can be formed through fusion without consuming more energy than is released. Iron is a cosmic energy sink, a point where the balance of fusion breaks down. When iron begins to accumulate in the core of these stars, it marks the end of their productive life. At this point, the star can no longer sustain the fusion process and begins to collapse under its own gravity. It is the beginning of the star's demise, the transition from life to death. This is a critical moment in the life cycle of a star. And for these massive stars, it often results in a supernova, a colossal explosion that releases a tremendous amount of energy, brighter than an entire galaxy for a brief time. During a supernova, elements heavier than iron, such as gold, platinum, and uranium, are formed in the extreme heat and pressure of the explosion, scattering these heavy elements throughout the universe. These supernovae are the ultimate creators of the universe's heaviest elements, enriching the cosmos with the raw materials that will one day form planets, moons, and life itself. As you float within the heart of one of these ancient, massive stars, you witness the extraordinary pressures and temperatures that allow this stellar alchemy to take place. Inside this star, temperatures exceed millions of degrees, and the pressures are so intense that they are capable of squeezing atoms together to form new, heavier elements. This is not just a process of destruction, it is a creative act, an act of constant renewal that sustains the universe's evolution, seeding it with the ingredients for new generations of stars, planets, and life. One quirky tidbit about this process: iron is the heaviest element that can be formed through fusion before the process becomes a drain on a star's energy. This makes iron a kind of cosmic tipping point. When a star reaches this limit, it can no longer sustain its fusion reactions, and the collapse into a supernova follows. The star's core implodes, and the outer layers are blasted outward in a violent explosion, creating some of the most spectacular and energetic events in the universe. Section 12. The Planetesimal Dance. From the dramatic explosions of second-generation supernova, which seeded the cosmos with heavier elements, our journey now shifts focus from the grand scale of stellar death to the more intimate ballet of cosmic construction, the planetesimal dance. Imagine vast clouds of gas and dust, enriched by the remnants of exploded stars, beginning to slowly coalesce and organize. But not into new stars. Instead, they are becoming something even more intimate, more foundational, the nascent building blocks of planets. It's as though the universe is playing with cosmic Legos, assembling worlds one tiny piece at a time. This era began billions of years after the Big Bang, within the swirling, dynamic protoplanetary disks surrounding newly forming stars. In these disks, microscopic dust grains, now infused with carbon, silicates, and various ice-forming molecules, the remnants of earlier stellar alchemy, remember those heavier elements from Section 10, begin to stick together. Through the process of accretion, these dust particles gradually clump into larger and larger aggregates, moving from tiny specks to pebbles, then rocks, and eventually to kilometer-sized objects known as planetesimals. This process is driven by electrostatic forces at first, static cling on a cosmic scale. But as the objects grow larger, gravity takes over, pulling them together into ever larger bodies. Imagine yourself floating within one of these dense, swirling protoplanetary disks where countless tiny particles are moving in a slow, graceful dance. The energy is palpable, though silent, like the motion of particles in the air, invisible but essential. Here, in this cosmic nursery, the universe is in its early stages of world-building. It's a process that seems almost organic, each dust grain finding its place, joining together to become something more. One quirky tidbit about planetesimals is that they are essentially the leftovers from star formation. Not all the gas and dust in a protoplanetary disk falls into the central star. A significant amount remains in a flattened disk around it. This is the very material that forms planets, moons, and asteroids, the cosmic crumbs that, through time, will become the delicious planetary cakes. These planetesimals are the raw ingredients from which entire solar systems will be sculpted. As these planetesimals grow in size, they begin to collide and merge, often in a delicate yet sometimes violent dance. Some of these collisions are gentle, where small planetesimals nudge each other and combine over time. Others are catastrophic, with massive impacts leaving craters and ejecting debris, accelerating the process of growth. Over millions of years, these impacts build even larger bodies, planetary embryos, the early stages of planets. The environment is chaotic, an ongoing clash of cosmic forces, a primordial battle of creation. The process is unpredictable and volatile. As you float here, you witness the birth of new worlds, where planetary embryos gather mass, their surfaces molten, and their atmospheres still in flux. The specific composition of these planetesimals depends heavily on their distance from the central star. Closer planetesimals, within the inner part of the disk, are rich in rocky materials, silicates and metals, the building blocks for terrestrial planets like Earth. Farther planetesimals, beyond what's known as the frost line, are rich in ices, water, methane, ammonia, compounds that can freeze solid at the cooler temperatures of the outer regions. These icy planetesimals will eventually form the cores of gas giants like Jupiter and Saturn. It's a time of immense foundational construction, a cosmic sculpting where the very first stages of planets are being laid down. But this is not a simple process. The universe's building blocks are not rushing toward perfection. They are stumbling toward it. There is a messiness to it all. Worlds are being assembled out of the remnants of earlier stars, and sometimes the pieces don't fit perfectly. There are gaps, collisions, and fragments left behind. But slowly, steadily, the universe is building a collection of worlds, one tiny particle at a time. As you drift within this swirling maelstrom, the movement around you is both chaotic and strangely graceful.
You feel the tension of creation. There is a rhythm to this dance, a steady accumulation of matter. Each collision, each aggregation brings something new into existence. Some of these planetesimals will collide with enough force to create moons. Others will remain solitary, orbiting their parent stars as asteroids or comets. But all of them, in their own way, are part of the grander plan, each a unique note in the symphony of creation. Section 13. The Birth of Solar Systems. From the intricate planetesimal dance, where countless cosmic pebbles slowly coalesced into the building blocks of future worlds, our journey now brings us to a truly luminous stage, the birth of solar systems. Imagine a particularly dense cloud of gas and dust, a cosmic nursery, enriched by the remnants of exploded stars, finally collapsing under its own gravity. As it contracts, it begins to spin faster, flattening into a rotating disk. At the heart of this disk, the central mass becomes so dense and hot that it ignites, giving birth to a star. Around this star, the worlds of the future begin to form, drawn into its gravitational embrace and starting a majestic orbital ballet. It's as though the universe is presenting its grand architectural masterpieces, each a self-contained celestial dance. This process began billions of years after the Big Bang, following the formation of second-generation stars, those rich with the heavier elements created by earlier generations of stars. This was a key moment, as these heavier elements, such as carbon, oxygen, and iron, forged in supernovae, are the essential ingredients for forming planets, moons, and the complex systems we recognize today. The process starts with a vast molecular cloud, a diffuse collection of gas and dust that is both the birthplace and the raw material for future solar systems. Our mainstream historical fact is that these molecular clouds, now enriched with the heavier elements from previous stellar generations, remember the stellar alchemy from Section 10? Begin to collapse under their own gravity. As the gas contracts, the cloud begins to spin faster, conserving angular momentum, and flattens into a rotating disk known as a protoplanetary disk. At the very center of this disk, the pressure and temperature build up to the point where nuclear fusion ignites, giving birth to a star. Our Sun, for instance. Around this newly ignited star, the rest of the material in the disk, composed of planetesimals, dust, and gas, continues to collide and accrete, eventually forming the planets, moons, asteroids, and comets that will orbit the new star. This process is much like the universe organizing its scattered toys, putting them into place to form a perfectly balanced perpetual motion machine. The forces at work are immense, and the choreography of celestial bodies unfolding in these early systems is breathtaking. You find yourself floating in the midst of this nascent solar system, surrounded by swirling gas and dust as the central star flickers to life. At first, its light is faint and tentative, but slowly it grows in intensity, pushing the surrounding gas and dust away, clearing the path for the nascent worlds to take shape. The birth of the star is a slow and beautiful process, akin to the opening of a cosmic flower, revealing the planets and moons that will one day orbit it. You witness the immense gravity of the star beginning to dominate the region, pulling everything around it into a steady rhythm, like an orchestra conductor guiding an intricate ballet of planetary bodies. One quirky tidbit about solar system formation is the concept of planetary migration. It's thought that many planets, particularly the gas giants, didn't form exactly where they are today. Instead, their positions were influenced by gravitational interactions with the disk of gas and dust around them, as well as with other forming planets. This means that planetary migration, the shifting of planets' orbits, was common in the early stages of solar system formation. Some planets migrated inward, while others migrated outward. This chaotic dance can actually sculpt a solar system, sometimes even ejecting planets entirely, causing them to be flung out of the system. For example, our own Jupiter may have once formed farther from the Sun and gradually migrated inward, reshaping the structure of the early solar system. So, your home planet, Earth, might have had a very different address at some point in the past. As the star ignites and becomes the dominant gravitational force in the system, it begins to establish order.
The planets start to settle into their orbits, with each world finding its place around the central star. Moons begin to form around the planets, and the remaining gas and dust in the disk slowly clear out, leaving behind the solid bodies that will make up the planetary system. The planets themselves start as rocky and icy bodies, some larger, some smaller, and over millions of years, they will continue to accrete material from the disk, growing larger and more complex. At this point, the solar system is no longer a chaotic cloud of gas and dust. It is a self-contained, organized system, with a central star, planets, moons, and other small bodies, all following their own delicate paths. The star, with its massive gravitational pull, has brought order to the system, and now the planets are orbiting in a stable, almost hypnotic ballet. This is the universe, now filled not just with stars and...
Section 15. The Legacy of Creation. As the last whispers of our long, gentle journey through the history of creation, guided by the grand narrative of the cosmic blueprint, finally begin to fade, you find yourself lingering in a moment of quiet reflection. You pause, contemplating the truly enduring legacy of this grand cosmic story. From the initial cosmic whisper of pure potential, remember back in Section 1, through the unfathomable energy of the first spark, Section 2, the endless stretching of space, Section 3, the intricate dance of subatomic particles, Section 4, the harmonic emergence of fundamental forces, Section 5, the cooling cosmos and the birth of the first atoms, Section 6, the quiescence of the Dark Ages, Section 7, the first light of stars, Section 8, the formation of majestic galactic nurseries, Section 9, the internal alchemy of stellar cores, Section 10, the dramatic rebirth of new stellar generations, Section 11, the painstaking formation of planetesimals, Section 12, and the grand orbital ballet of solar systems, 13, the universe has been an unwavering, silent testament to an unfolding design. It has witnessed the very inception of existence, the forging of matter, the weaving of space-time, and the continuous, intricate unfolding of all that is. Through every epoch, from the infinitesimal singularity to the vast cosmic web, this underlying blueprint has remained, a potent symbol of inherent order, profound potential, and boundless creation. Its significance extends far beyond mere scientific description, touching the very soul of humanity. You envision the grand tapestry of creation, woven with the precise threads of physics and the vast expanse of time. Each layer of the cosmos, from the birth of particles to the formation of galaxies, is interconnected, each piece contributing to the whole. There is an ancient underlying force still at play, a force that governs the motion of galaxies and the interactions of atoms. The cosmic forces that shaped the universe, those fundamental laws, continue their work, seen in the rotation of planets and in the fusion of elements at the cores of stars. Perhaps you sense the profound reality of your own existence, a direct descendant of that very first spark, a tiny yet significant piece of the cosmic blueprint. You are not separate from the universe, you are part of it, intricately woven into its fabric. From the hum of your heartbeat to the thoughts within your mind, the universe echoes within you. It's a powerful reminder of continuity, of the quiet, persistent power of the universe, and the myriad ways in which its fundamental laws intertwine with existence itself. The universe's remarkable journey through time and space is a living testament to its incredible resilience, its innate ability to self-organize, and the profound, unbreakable connection between all things, from the smallest quark to the largest supercluster. The cosmos has proven that even in the face of unimaginable temperatures, immense pressures, and billions of years of expansion, true value and inherent order endures. Its constant unfolding is a story of creation, not only of stars and galaxies, but of the very laws of nature that govern how everything behaves, interacts, and evolves. The universe's evolution is a testament to the incredible balance it maintains and to the beauty that arises from that balance. From the quietude of the primordial void to the brilliance of the stars, there has always been a grand design, a subtle but unshakable order underlying all things.
Its omnipresence in our collective consciousness, from the profound mysteries of quantum mechanics to the awe-inspiring images of distant galaxies, speaks volumes about the universe's undeniable impact on our understanding of reality. Scientists and philosophers continue to engage in thoughtful debates. Does the universe's profound elegance and fine-tuning stem primarily from its inherent mathematical properties and the random interplay of forces, or from an underlying guiding intelligence that set the very parameters for its existence? Perhaps it is an inseparable and synergistic fusion of both, where the inherent rules allow for astonishing complexity and the emergent beauty of the universe elevates our understanding of the world around us. The profound stillness of creation, that quiet potential before the first dawn, stands today as it did at the beginning. It is a quiet companion, a silent observer of all that has unfolded, and a steadfast provider of the very fabric of reality. It continues to amaze our minds, inspire our spirits, and humble our understanding, just as it has for billions upon billions of years. It asks for nothing but gives everything, a truly magnificent example of cosmic generosity. It's a quiet companion, a silent observer, and a steadfast provider.